Okay, so good morning, guys. Welcome to math class. We're starting up right now. Right. So just really quickly, I told some people here that were here earlier, make sure you check the left-hand side of our iLearn Classroom page for some announcements. These are going to stay up for the whole course. They're just relevant links that you're going to need as we go forward, right? Also, if you happen to be late to class, you happen to miss class, don't forget to check every day. What I'm trying to do is I'm posting up the recorded session. So right here, this is the recorded session from yesterday. You can watch that. Same thing, the recorded session for the day before. You scroll down a little bit and it's over here. So I posted in this, a post here just explaining that what we're doing today is lesson 2 rates. And after the class is over, I'm gonna upload to YouTube and then post that link here as well so you can rewatch it later if you missed something, okay? So, like I said, today we're doing lesson 2 rates. So you wanna make sure that you're going over to Edmentum. You click through to open up the Edmentum window. I'll give you guys a second to do that. And what we finished so far is we finished the first lesson yesterday, which was ratios, right? Remember, a ratio is just a comparison between two quantities. What you should have done yesterday is you should have finished that mastery test. If you're not done with it yet, try to make sure you get to that as soon as possible so that you don't end up falling behind and have like 3 or 4 mastery tests that you end up having to do at once, okay? What we're doing next is lesson 2. It's on rates. You're gonna see that next week, we're gonna get then to the mastery test on Monday. Then we're gonna get to the next lesson is tables of ratios, applications of rates. Then we get to our next unit, which is expressions and equations, okay? So, give me a second, I'm just adding people in as they come in late. If that's why it seems like I'm just stopping abruptly, that's probably what I'm doing, okay? So, again, we're gonna open up that next lesson, which is on rates. And just make sure that you have it open so that you can follow along with me and you can ask me any questions that you might have along the way, okay? So when we're talking about rates, let's just first get to the objective for today, right? It says, in this lesson, you will explore the concept of a unit rate and use rates to describe ratio relationships, right? Can anybody give me an example of a rate? Any example of a rate that you can think about? All right, guys, if you're typing questions in the chat that's not related to this right now, just try to hold those off until I finish going over this content, and then I'll try to answer you guys later, okay? So to actually help give you guys an example of a rate, I'm gonna show you a quick YouTube video that I found online that reminded me of what we're doing today, okay?
You're going 80 miles per hour. How long will it take you to go 80 miles?
Okay.
Why do you keep asking? What is it? I don't know. I said 10 minutes and you said no. And then I said 80 minutes and you said no. And then I said 8 minutes and you said no. Miles per hour. How long will it take you to go 80 miles? What? Okay, if you're going 80 miles per hour, how long will it take you to go 80 miles? Yeah. I don't understand. I can't pronounce this. Okay. 80. So do I like divide something? 80 miles per hour. How long does it take you to go 80 miles? Yes. I don't know, dude.
Okay, so in case you're having trouble hearing it from the audio, because I know sometimes the videos do lag in Zoom, the question is, if you're in a car that's going 80 miles per hour, how long does it take you to go 80 miles, right? And this goes on for another 2 minutes. There's actually a lot of different videos on YouTube that people ask the same question, and we always see that there are people that are confused with it. They have trouble answering. So what she was saying again was, if a car is going 80 miles per hour, how long will it take you to go 80 miles? That's the question. Does anybody think that they know the answer to that? Okay, so Logan's correct. It's 1 hour, right? Now, it's actually something that's not confusing, but I think people spend just time getting caught up. They think that they need to do something with the numbers there, right? In essence, right, that number, 80 miles per hour, is an example of a unit rate, which is what we're talking about today, right? It's actually 80 miles per 1 hour, right? They're just leaving off the word one. So what that means is that every 1 hour, the car is traveling 80 miles. So after 2 hours, how far would the car have gone? Feel free to use the chat, say it out loud. Okay, good. So Sissy asked, how did we get 1 hour? Logan, you think you could explain again how we got 1 hour?
Well, because every hour, every 80 miles, it goes 1 hour. So it's like, how many hours will it take 80 miles, right? So it's an hour.
Right. So the thing there is that it's a unit rate. So we're saying it goes 80 miles per 1 hour. We just always leave off the word one because it's assumed that you're talking about one. So that means that if you drove for 1 hour, you're going to go 80 miles. You're basically just flipping it around, right? So that means that if you drove for 2 hours at 80 miles per hour, you would go 160 miles because you're just doubling it, right? So when we're talking about rates, unit rates, they're really just ratios, but specifically what we're going to see today is that they're ratios where one of the quantity is 1. That's what it means when we're talking about something being a unit in math. That typically means we're talking about one of something. Right? And again, just try to make sure that you're following along with me at the same time at mental, okay? So let's just read through the scenario here. It says, Shannon loves going to fairs. This summer, Shannon's mother is taking her and her friend Emma to the Marion County Fair. Shannon and Emma are excited about trying the rides because they are now old enough to ride without an adult. They plan to go on every ride using the fun passes that Shannon's mother bought them. A fun pass gets you 20 tickets for $10, right? So remember, right, when you guys are working, that there's this highlight tool here. And anytime I'm reading a math question, what I like to do is I like to underline or highlight whatever the key information is, right? This is math class. When we see numbers, you should say, okay, those numbers, those are probably going to be important. So a fun pass gets you 20 tickets for $10. It says Shannon wants to know the cost of just 1 ticket, right? So in this lesson, we're going to figure out how to do that and how to work with some other rates, okay? Again, just please stop. Let me know if you have any questions before I continue to move on. So it says here that we know that a ratio is the comparison of two quantities that have the same unit of measure. Remember, that's what we did yesterday. We were talking about those part-to-part ratios where we were comparing, you know, cups of apples or cups of pears. So that's comparing quantities that have the same unit of measure, right? But it's saying when the two quantities have a different we call it the ratio of rates. We're talking about speed, right? We're talking about how fast things move. We might say that that thing moves per 1 hour, right? So we got it like a ratio. 60 over 1. We can read it as 60 with a colon to 1. A sentence, right? So just like we talked about the different ways to express ratios, we can do that. But when the units are different, right? A mile and an hour, those are totally different units. Miles measure how far away something is. Hours measure how long it takes to do something, right? When we have different units, instead of referring it to as a ratio, we refer to it as a rate, right? So rates are really just ratios, right? Same thing. Give me a second, someone keeps getting kicked out of the Zoom session. For now. So going back to that example from before, right? We know that Shannon, for those tickets, paid $10 to get 20 tickets. The question said before, I'm interested in how much it costs for just one of those tickets, right? What's the value? So when we talk about finding a unit rate, and Logan, yes, you are correct, right? When we find a unit rate, that's for how much it costs for one ticket, right? Costing $10 for 20 tickets, we say is a rate. The unit rate would be the price for just one ticket. And if you're paying attention to the chat, Logan just gave that cost to us, which we're going to discover in a couple of minutes, right? So again, it's saying right here, to find that rate, we just take the total cost of the tickets divided by how many tickets we found. And this is a fraction. Remember, fractions are just examples of ratios. Yeah, so no, the math you're going to have to do in Edmentum, but along the way, I'm going to ask you guys questions, and people can respond to my questions by typing them in the chat or by saying it, just unmuting yourself and speaking them out loud, right? But you do want to also make sure that you are submitting the work inside Edmentum here so that I can physically go in and see what you've been doing, all right? So now we're talking about rates and unit rates, right? So remember, it told us that to find the rate, we're going to set up a ratio where we have the total cost of tickets divided by the total number of tickets that were purchased. So back to that, sorry, let's look at this example here, right? This is saying, what if for this example, somebody bought 6 tickets and they spent $12 for that? All right, I'm gonna explain that when we get to the practice part, Alice, okay? So basically what we're thinking about is the main question for this page and the next page. I'm gonna write it at the top. So the main thing that we're thinking about is how much is one ticket? That's the main question that we're thinking about here, okay? So for this next scenario here, it's telling us that somebody goes and they buy 6 tickets and they spend $12. So I know how much 6 tickets cost, but you kind of want to try to figure out how do we work backwards to figure out the price of just one of those tickets. Give me a second, I'm just still adding people in. Right? So if we know 6 tickets cost $12, the way that we figure out the price of one ticket is we basically need to figure out how much money did we spend, right? We spent $12. So the total cost spent is $12, and then we say, how many things did we buy? We bought 6 tickets. So to figure out the unit rate here, all we have to do is take the total cost of the ticket. So remember, the tickets cost $12. We find the total number of tickets that we bought. So the total number of tickets was 6 tickets. So that gives us this ratio, or this fraction, 12/6. Remember, fractions are ratios. So for $12, we get 6 tickets. So if I want to find the cost of one of those tickets, all I do is I divide 6 into 12. So 12 divided by 6 gives you 2. And you can check to see if that works, right? So what this means here, this means that $2 is the cost of just one ticket. That's the unit rate. Right? So really this $2 means $2 per ticket. So if it's $2 per ticket and I bought 6 tickets, 2 times 6 gets me to $12. So I can check my work and I see, okay, so that does work. That does make sense in this example here. Now, let's go back and see if we can do the same thing for that previous question that we just saw, right? Okay, now right now in a few minutes. So for this example, we were talking about she paid $10 for 20 tickets. So if we paid $10 for 20 tickets, what do we do to figure out how much just one of those tickets is going to cost? I need this right now. Thank you. So The same formula is right here. To find the rate, it's the total cost of the tickets divided by the total number of tickets that we've purchased. Now, in math, it sometimes helps to, before you find your answer, try and think about how big your number should be, right? So if we spent $10 for 20 tickets, do we think an answer like, say, $4? Right away, can somebody tell me, would this answer make sense for the cost of just one ticket? Could they possibly be this expensive? Would they be more than that? Would they be less than that? Okay, I'm seeing Logan say no. Can I get somebody else to share what you think? Yes, no, what do we think? $4. Could these tickets possibly cost $4? Why or why not? Okay, now, $4, right? If I bought 20 tickets, that means that altogether I would multiply to get the cost. 4 times 20 is gonna give me something that's way bigger than $10, right? So when you're working with math, especially when you're talking about money, you really wanna think about your answer, think about if it makes sense. So if somebody somehow got $4 as an answer, I would say, no, that is way too big. This 4 I just gave up as an example. I just said, could it be $4? Right? What about $2? Do you think that it could possibly be $2 per ticket? Again, I'm just giving you guys numbers. Right? Now, in this case here, again, I bought 20 tickets, I spent $10, so could they possibly be worth maybe $2 for every single ticket? Right? And if you're not sure, really quickly, all you would have to do is you'd say, okay, so let's see. If they were $2 each, 20 tickets multiplied by $2 each would give me a value of $40, right? Which is way more than the $10 that we spent. So you might start to think, okay, so is it possible maybe, are the tickets worth $1 each? Are they more than $1 or are they less than $1? Just wait for somebody. Okay, so Logan says less than $1, right? So same thing, Jinghao, good, right? We should be able to figure out by looking at these numbers here that they have to be less than $1, right? That tells you that when you get your final answer, if you got something that's bigger than $1, you did something incorrect. That's the way you can kind of check your answer. So in this case here, if I bought 20 things and I spent only $10, there's no way they cost $1. They're gonna have to cost a lot less than that, right? So it's just helping you to think rationally and try to figure out what the answer is before you even do the math, right? But the way that I find that is pretty simple. All I have to do is figure out how much I spent on the tickets. So they spent $10 on the tickets. Altogether, we bought 20 tickets. So you set up this ratio here and you divide. And yes, that is cheap, right? So probably not gonna be this cheap in an example if you went to like, say, Coney Island, but places do usually discount things if you buy them in bulk, right? So it might be cheaper if you bought like 100 pack of tickets compared to if you bought one at a time. And the way you can figure out how much of a deal you're getting is by doing a simple calculation like this, right? So 10 divided by 20, just be careful, it's not 2, right? Because also, right, students might make a mistake here. They might say, okay, so 20 divided by 10 is equal to 2, and then say their final answer is 2. But if you took some time to think about this first, you might say, wait, no, it can't be 2, that's too big. Remember, right? We said it has to be less than $1. So it's not 2, it actually ends up being 1/2 or 0.5. Just remember we're talking about money. So 0.5 is half of $1. That's really just 50 cents, right? So if we're buying 20 tickets and spent $10, that means that realistically, we're actually just spending 50 cents for every one of those tickets, right? So 2 tickets together cost $1. 10 tickets would cost $5. The 20 tickets together cost $10 there, okay? Does anybody want me to go over any of that part again? Right, it seemed like some people were starting to get it as I was going. And good, Logan mentioned that we can check our answer, right? With math, you can always check your work. So if we did say, okay, so we spent 50 cents for every ticket, I want to multiply that by 20 tickets, you're going to find that that's going to give you $10, right? That's how you check your work to make sure that you did it correctly, okay? All right, so this was the different example where you spent $12 for 6 tickets, divide, you got a rate of $2. All right, so the next part is an activity. I'm gonna help just get you started on the first part. And then the idea is that you're independent learning, you're working through the rest of this section on your own, and also the rest of the slides. So there's 17 slides today. The idea is that you finish a section, you go on to the next slide, you're gonna have some stuff to read, you're gonna have some stuff to practice as well, okay? Just take your time with it, right? I'm gonna help you get started on this part here, and then I'm gonna stick around to help students that have questions and just to be a support until 9:30, all right? But at this point, you guys are gonna be working independently at our levels, okay? So first part just kind of gives you some ideas of what you're gonna be learning, why you're learning it, the mathematical practice that you're using, all right? But directions down here, it says read the instructions for this self-checked activity, type in your response to each question, and check your answers, right? So checking your answers is something that's really important, right? You definitely want to get in the habit of doing that because a lot of students, right, and I find even ones that are operating at higher levels, you make mistakes, right? Everybody makes mistakes. I make mistakes too. So in math, it's really easy to find out if you made a mistake. So anytime you answer something, if you want to be 100% certain that you got it right, there's no reason to say, hey, Mr. Correa, is this answer right? Because you can check yourself if it's right? You might say, I'm not sure how to get started. I don't know how to find an answer. But a lot of times you shouldn't say, is this answer right? Because you can yourself can check to see if it's right. All right, so let me get you started on this section here. It says that Shannon is at the fair. She has already been on a couple of rides, and now she only has 13 tickets left. Okay, so again, that looks important, so let's highlight it. It says she wants to use her tickets wisely to get the maximum ride time with her remaining tickets, right? So she's not concerned about how fast the things are going, how high they're going. The only thing, I'll be hold on a second. The only thing that she's worried about is how long she's spending on these rides here, okay? Now, it says she wants to find the rates, right, unit rate, ride time per ticket. So she wants to figure out for each ticket that she's gonna use on these rides, how much time is she gonna get actually sitting on a roller coaster or some type of ride, right? The table down here shows a couple of different things. So on the left-hand side, we've got the name of the rides that she's looking at. So we've got a Ferris wheel, a tilt-a-whirl, spinorama, bumper cars, straight up, and a carousel. It tells us how much tickets it costs to go on that ride. Remember, she only has 13 tickets left. So she could go, on the Ferris wheel 13 times. She could go on the tilt-a-whirl 6 times and then go on the Ferris wheel once. But remember, what she's trying to do is she's trying to get the maximum ride time. And the ride time is given to us over here on the right-hand side. So if she's on the Ferris wheel, that's gonna be close to a minute long. If she's on the tilt-a-whirl, that's gonna be about half a minute, right? So each of these rides are gonna be for a different length of time, right? But remember, they all cost a different amount of tickets. It's not like every single ride only costs 1 ticket, right? If that was the case, this would be an actually very simple question, right? Could somebody tell me, if every single one of these rides only costs 1 ticket, what ride should she stick with to get the maximum amount of ride time? We can say it out loud, we can write it in the chat. Okay, good, the Ferris wheel, right? So again, that's a very easy question if they all cost the same amount of tickets, mainly because the Ferris wheel is the longest ride. But that's not the only thing that we need to consider, right? Because we might have a ride like this, right? Does this seem like it's gonna be a good ride for her to go on if she's trying to maximize her ride time? No, right? because it costs the most tickets. Well, it's tied with something else for the most tickets, and she's only getting 15 seconds. So the Ferris wheel is definitely going to be a better bet than that. All right. Okay. It might be a rip off, but we also think a Ferris depends what you're looking for in an amusement park. A Ferris wheel is just going to go around slowly. It takes you up high. You get to see. Straight up is probably something like a slingshot that's going to rapidly shoot you straight up into the air, and then you come back down. So depending on what you're looking for, right, the length of time that you're on there isn't always the big thing that people are looking for, right? If I was going to an amusement park, personally, I would probably want to go on stuff that goes high and fast than something that's going slow. Unless I'm with my daughter, she might enjoy the Ferris wheel a little bit more, all right? But again, the main idea here is she wants to maximize ride time. So what she's trying to figure out first is how much ride time is she going to get for just going on one ticket. Sorry. How much is one ticket worth for the ride time, if that makes sense. So to help us do that, we're going to figure out the unit rate for each of these examples here. They gave us the first example, right? Remember the equation that we're using in this case, it's a little bit different because we're not talking about cost. Instead of figuring out how much it costs for one ticket, we're trying to figure out the ride time for each ticket, right? So what we're going to take is you're going to just take the ride time, so how long you're sitting on that ride for, and just divide by the total number of tickets that it costs for that ride. You're going to type your responses into this table here, into these blank spots. So they gave you the first one, right? For the Ferris wheel, it's 55 seconds divided by one ticket. And then you just have to divide it. 55 over 1 equals 55, right? I believe there is also a calculator function built into Edmentum here. So you can click on calculator and do your math right on the left-hand side over here, right? So you would just do top is 55 over 1 equals 55. So you're going to do those for this section here, and then you're going to start to move on to the rest of the questions. All right, so at this point, I'm pretty much done going over the lesson for today. I'm going to stick around for the next about 17 minutes to just help support you guys, answer any questions. If you want me to go back a slide and explain something else, or you have questions about anything in the lesson, just let me know and I'll try to help you guys out with that stuff. Yes, that's my daughter Penelope. She's climbing under my chair right now. So it's not that it's homework, it's that it's the rest of class, right? So again, we have these live sessions. I'm available until 9:30. And then for the next hour, right, between 9:30 and 10:25, I have it on the schedule. That's when you guys are expected to be doing your independent learning, right? So homework, you guys are all home right now, but it's continued classwork, right? I'm still here. I'm going to be available for that whole time. If you guys have questions, once it's up to the independent class time, don't forget that on the course page, just send me an email. I can try to help you out, all right? Yeah, so if you don't have any other questions at this point, you're free to head out of the Zoom session, and I'm going to stick around for another, again, 16 minutes to help support you guys with this stuff. And then you're going to be going to ELA at 10:30.
Hi, good morning.
Hey, good morning.
Sometimes when I go to the lessons, they ask me for account number. Do you know what's the account number?
When you click on Edmentum,
Yeah.
hold on. So you're saying like when you click on this here, all right, Noah, so follow along here, right? The way that you get to that math work that I've been showing you is from the iLearn course page. You click on, I love you, please stop. No, right now. You click on the Edmentum link here. That's gonna give you something that looks like this. In the middle, it says open a new browser. You click on that, that's gonna take you over to the math. Oh, Anthony, you don't have to actually go ahead. You don't have to put the fraction in. If you want to, you can type it out. Like for this example here, you would type it as like, 30, you could just say /2, and then you can say equals whatever it is. But you can also just write the answer in. Right, Noah, right? So from the course home on iLearn. Actually, Noah, are you in the math section or are you looking at the ELA section on iLearn? Do you see welcome to 6th grade math? Okay, so you're in the math, so you'd want to scroll down to the left-hand side. You'd want to click on Edmentum Math. You're going to see a little, might have to just click on it twice.